Hello, algebra students.
This is a video that is going to go through several of the examples found in a chapter on graphing translations of trigonomic functions. Okay, so the basic premise is that a trigonomic function, the sine and cosine look like this nice little wave here, and the tangent looks a little bit different. We'll see that very shortly. But when we subtract a number away from the x variable inside the parentheses, and this f here, that could be sine or cosine, then what we have is a function that will move to the right. Correspondingly, when we're adding something in here, it'll be moving to the left. Now, right and left is great, but what about up and down? The up-down part comes down to this. When we add on a number and we designate this as k, then the vertical translation will happen. We add, like, a 2, and everything will go up by a factor of 2. Now, before we dive into it, there's a couple settings that I'd like you to check on your TI-83 Plus or TI-84 Plus graphing calculator. We are going to be changing the mode. Now here you see I've got radian selected. It could be that maybe your calculator is already set to degree, because throughout much of high school we do some mathematics that involve trigonomic functions that ask you to deliver an answer in degrees. But for this one, we're going to go with radians. So make sure it's radians. Click enter. Now then, we got that all set. Go into the y equals editor, and as you can see, I've got something in here already that from a previous exercise. I'm going to clear this out. And I'm going to begin by putting in a trig function. Here you see the three keys approximately in the middle of the keypad: sine, cosine, and tangent, the good old three. Sine x in parentheses. Now, let's adjust the window so that we can best view this function. So we're going to, before we even graph, we're going to press zoom. And we've got a number of different features here. Number 7 is Z-trig, and that means zoom to the best settings for displaying trigonomic functions. So I'm going to hit enter, and it automatically starts the graph. And here we have a sine function. And we notice here that sine, when x is 0, y is 0. And these tick marks, you might be thinking automatically in your head, oh, that's x1, this is x2, this is x3. But not so fast. Let's take a look at the window dimensions and see how often these little tick marks along the x-axis are being marked. When I click on window, we see that the x-axis goes down to negative 6.15 and as high as 6.15. That's okay. And you might notice that the scale on the x-axis, remember I said that it's not 1? It isn't 1. It's 1.57079. And you might be wondering, why on earth would setting the Z-trig zoom set the x scale to some bizarre number like this? Well, I'm going to show you something kind of neat here. I'm in the home screen, and I'm going to bring up good old pi. So here's a value of pi, 3.14. Now, if I divide 3.14 in half, I get 1.5707, that very same strange number that we saw in our window properties. And so what this means, when we take a look at our graph, is that this tick mark is at half pi, this is at pi, this is at pi and a half, and I'm betting that the very far right here of the window setting is 2 pi. And correspondingly here we go into the negative part of the x-axis. This would be negative half pi. Here's pi, and then this one is negative pi and a half, and here we go with negative 2 pi. And so this helps us see how the cosine function is graphed. Now, how about the y-axis? Is this pi right up here, or is this tick mark half pi? Well, let's take a look. We'll go into window, and Nope, it looks like our y minimum and maximum is set to -4 and +4, so it goes up and down a total of 8, and the y markings are at 1. So, you know what? I personally like to have a little bit of a tighter view, so I'm going to change this to -2 and then as much as 2. You can keep it at 4 if you want. So here we go. Now I've got this beautiful sine function. Let's take a look here at the cosine function. Now we've got all these different y slots. We can load in as many as 10, I think. And the purpose of this is so that we can compare two functions on the same screen and look at them at the same time. So let's take a look at what cosine looks like. Okay, so sine is going to graph first and cosine is going to graph next. Okay, sine is already drawn, and here's cosine being drawn. Neat. Alright, so cosine, when x is at 0, starts all the way at 1. And as we advance, it's sort of blurring the tick mark here, but as x increases to half pi, cosine becomes 0, and as we increase x, cosine becomes -1, and then we keep going on up here. Let's see, would this be -1 at pi? Well, let's take a look. We can always ask the calculator. We are set to radians, so let's see. Cosine at 0. Oh, there it is at 1. Cosine half pi. I'll put pi over 2. It's at 0. Well, let's see. What was cosine pi? This is a rapid way for you to actually see the values. Cosine pi is at -1. Okay, pretty good. Let's go back to our graph. Now we do have this key here, which is really, really useful, called trace. Boom, there we go. We've got this little spider, this little cursor right down here at the origin. And as we move the directional arrow keys to the left and to the right, we can see that as we step along the function, that our x and y axis is read out in real time. Unfortunately, we can't see like if it's half pi or pi or whatever, because we just see a decimal approximation. Now what we're doing is we are stepping through and tracing along our first function. Right up here you'll notice in the upper left hand corner, y1 is equal to sine x. So that is the function that we're exploring right now. This is a useful tool. Okay, so how do we explore that other function, y2? Okay, I think if we use the up-down directional arrow keys, there we are. Now we're on the cosine function, which is in slot y2. Again, the left and the right directional arrow keys lets us move along here, and we can actually see what our values are. Pretty spiffy. Okay, so I'm going to go into the y equals screen, and I'm going to clear out both of the functions. We're going to start fresh. Now, I did leave my window here to be a maximum of -2, the y-axis to go down as far as -2, and the y-max to go up as high as 2. And that was fine for what we were looking at, but what if we do something like we do a transformation of the trigonomic function? Like, let's say I multiply everything by 4, and then I graph it. What's going to happen? Oh. Okay, so we still have our nice sine function, but as you can see here, the peaks go off our viewable area, and so that's kind of where we need to kind of discriminate what we should set it to. -2 to 2 doesn't do it anymore, and I have a feeling it goes as high as 4 and as low as -4. Now I like to leave myself a little bit of space on either side of the y-axis, so I'm going to notch it up by 1. So I'm going to go as low as -5 and as high as 5. I hit regraph, and now we see a more reasonable picture of our sine function. Okay, so let's take a look at example 1 in the textbook. It's about identifying phase shifts. Now, a phase shift refers to when a trigonomic function goes to the side, either left or right. And so this is sort of getting us back into the frame of mind of what happens when we add or subtract a number and it's inside the parentheses. Here we see our new function, g of x, is defined as the old function, f of x, x minus 2. And it says here, it's kind of points it out to us, that it's moved to the right. You know, I don't know about you, but I personally think that this is non-intuitive. I mean, you know, we've got a negative 2. Wouldn't everything be thrown over to the left? You know, like we were looking at a number line, and you get used to number lines, and the negative numbers are over in this direction. Well, you sort of have to overcome that and join me with this idea of being in opposite land. When it comes to phase shift, we are in opposite land. If we subtract 2, we're pitching over to the right. If we're adding a number, like adding 4, we're pitching over to the left because it's opposite land. Let's take a look at what this looks like on a graphing calculator. This is a great way to explore this idea. Okay, so let's see. I'm gonna get rid of the 4 in front of sine. We're just gonna have plain vanilla sine function right here. I'm gonna change the window back to negative 2 and 2, and okay, so there's good old boring, nothing going on with my sine function. Alright, so let's compare and contrast. I'm going to put in the exact same thing, but I am going to add 2 into the x here. So let's see what becomes. Alright. It sort of looks like our function was, moved back, moved forward. That's the funny thing about a phase shift. Because the sine function is periodic, that means it's like an identical thing every how often. This part here is identical to this, and how far apart is it? It's 2 pi units. So yeah, we could say that it's been moved back 2 units, or it could sort of look like it's been moved forward, but it's up to you to understand exactly what the plus minus means here. How about subtract, and we're in opposite land, so we're going to pitch it forward a little bit. How about maybe just a tiny little bit, like how about 0.5? So it's going to move to the right by 0.5. So here's our regular sine function, and this has been moved forward just a little tiny bit by 0.5. Okay, moving on to example 2. I bet that you probably already know enough where you can handle this one without a problem. Use the graph of the parent function, that means like nothing's happening to it, y equals sine x at the left. Okay, there it is. Big deal. Sketch each translation of the graph in the interval from 0 to 2 pi. So this notation here means anything that's less than 0, we don't care about it. And anything that's bigger than 2 pi, which is 3.14 times 2 is 6.2 something, 6.28, we don't care about that either. So I think it would be a good idea to not only graph this function, but to take a look at the graph in this interval. Alright, so let's go to our window. And our x-min, remember we don't care about anything less than 0, so we're going to set the left boundary, x-min to 0, and the x-max boundary to 2 pi. Watch this. Bet you didn't know you could do this. 2, press the second key, press the exponent key to put a pi symbol in there, 2 pi. Bada bing, you move it away, and it automatically computes the right number. Yay! Alright, so let's see. Here we go. Oh, and that's the sine function moved to the right by half a unit. So let's see, little refresher. What are we doing? Sine x plus 3. Okay, we'll go down here. The x in the parentheses is not affected, nothing added or subtracted, but we're going to add 3 here. So I'm thinking it's going to be moving up. And my window coordinates are as high as 2, so I better adjust this. I'm going to set this as high as, how about 5? Okay, I'm going to hit graph now. Let's take a look. And look at that. It's been moved up 1, 2, 3 notches up. Okay, part B is asking us to move it to the right by pi over 2 units. Not a problem. Go down here. I'm just going to clear it all out. Sine x minus, and now we're going to put in a fraction, pi over 2. On the TI-83 plus calculator, you're going to have to do this. Put in parentheses pi and then divided by 2, end parentheses, and then close off your first set of parentheses so that you don't have like not enough lefts or rights. Okay, this will work just fine on the TI-84 plus as well. But let's go for elegance. So let's see how we can do this with an actual true fraction. Alpha plus the y equals button. This brings us to a shortcut menu where we can insert fractionals, n over d, numerator over denominator. There we are. And second pi over 2. And we close off the parentheses. Okay, window dimensions. Let's think about what we want here. -2 to 2. Okay, I think that might just about do it. We're going to hit graph. Uh-oh, window range. We're going to hit quit. Okay, let's check out our window range. We made it upset somehow. Okay. Whoa, this happens to me sometimes. It might happen to you too. The y min is set to -2, and I put the y max as being -2 by mistake. Let's just make that a +2, shall we? Okay, the teacher needs to get that right. I'm going to hit graph. Here's our parent function. And it looks like our translated trigonomic function has been moved to the right by pi over 2. Okay, let's take a look at example 3. And if you've watched this all the way up to 18 minutes, bravo. Okay, graphing a combined translation. Oh, this isn't so bad. Okay, this is where we're doing both at the same time. We're doing a phase shift where we're going to add or subtract something within the parentheses, and we're going to move it either up or down. And here's our interval, 0 to 2 pi. All right, well, let's give this one a try. Let's see if we can graph this one. Sine x plus pi minus 2. Okay, go down here. Goodbye, y2. So let's put in sine x plus pi inside parentheses, I'm closing it off, minus 2. Okay, I'm predicting that it's going to go to the left by pi units, and we're going to move it down to 2 spots. So let's see. Here's the parent function. And, whoa, Okay, well, our interval is good, but we can't really see where that other function went. I mean, it's down here. It sort of looks like a reflection. It's not really. It's just been moved down and over. So here we go. Change the y min and y max. Let's make this -5. And here we are. There, we can sort of see how it's going. Okay, so this point here has been moved to the left from here, and this little downward slopey area here is down by 2 units from here. Okay, anything left? Okay, doing this with cosine is not any more difficult. It's just a matter of putting in cosine. Oh, I think I need to show everyone here how tangent works. Okay, tangent is a slightly different ball of wax. I'm going to put in tangent x, and we're going to graph it over the same domain. Okay, looks more like a snake trail here. I'm going to change my window so we can see a little bit more of it. I'm going to change my y maximum from 2 to 5. Okay, regraph. Okay, what the calculator is not showing you is something called an asymptote. There is this boundary, this line that passes right through half pi intervals. Right here, my cursor is going up and down, that it can't be graphed. So right there and right here, same kind of thing. Let me change my... Let's see more of this here. Instead of with 2 pi, how about 8 pi? This way we get to see more of it. Roop, zoop, zoop, zoop. Okay, there we are. Now when I said it's a whole different ball of wax, I did not mean that it is a whole different ball of wax in regards to translating the function around. If we add 1 and we subtract 2, it will correspondingly move it to the left by 1 unit and down 2 units. Yeah, hard to see without the parent function there to compare, but it works the same way. We still manage h and k the same way. All right, well, I hope this helped a little bit. If you've got questions on how to put your calculator in the right mode, or you've got follow-up questions regarding these examples, please do webmail me or call me. I will try to be available for you. Thanks for watching.